Hi folks, we're starting a new topic today, recurrence relations. So first of all, I'm going to explain to you what is meant by a recurrence relation, and then we are going to be looking at how to evaluate terms in a recurrence relation. So first of all, a recurrence relation generates a sequence of numbers where each term can be calculated if you know the ones before. So you're calculating terms in a sequence based on the previous term. So we use a specific piece of notation for a recurrence relation. The formula for a linear recurrence relation is un plus 1 equals aun plus b. Now that's completely new to us. We've not really seen notation like that before, but it is quite simple. Un plus 1 just stands for the next term in our sequence, and un stands for the previous term in our sequence, and a and b are just numbers. So stated simply, to get the next term in your sequence, you're taking a number and multiplying it by the previous term in your sequence and then adding on another number to it. So we'll look at a couple of examples here. So a recurrence relation is defined as un plus 1 equals 3un minus 6, and it's got with u0 equals 5. Now this u0 equals 5 is just the first term that they're giving us of our sequence, okay? And we are asked to find the value of u2. So first of all, we're going to work out u1. Now u1 will be equal to 3 times the previous term, so 3 times u0, take away 6. So if we do 3 times u0, so it's 3 times 5, and we subtract 6, so we get 3 5s are 15, obviously take away 6, gives us 9. So that's the value of u1. To then go on and get the value of u2, using our recurrence relation rule, it will be 3 times the previous term, so 3 times u1, take away 6. So u2 is going to be equal to 3 times 9, take away 6. And obviously 3 9s are 27, take away 6 gives us 21. So 21 is the value of u2. Now I'm going to ask you to pause the video and attempt the question on the right hand side. Right, hopefully you've had time to attempt the question on the right hand side, so we'll run through it. A recurrence relation is defined as un plus 1 equals 2un plus 0.5 with u0 equal to 6. Find the value of u3. So we're trying to find u3 this time. We're going to have to find u1 and u2 before we can get up to u3. So u1 will be equal to 2 times u0 plus 0.5. So u1 is 2 times 6 plus 0.5, which gives us 12 plus 0.5, which gives us 12.5. u2 is then equal to 2 times u1 plus 0.5. So we get 2 times 12.5 plus 0.5. And if we work that out, we end up with 25.5. u3 then is equal to 2 times u2 plus 0.5. So that gives us 2 times 25.5 plus 0.5, which gives us 51.5. To a couple of similar examples then. The first one here, a recurrence relation is defined as un plus 1 equals negative 0.5 un plus 4. And we're told that u4 is 16. We've to find the value of u6. So big difference here is that we're starting with u4 and we have to work out u6. Now it doesn't actually change what we're doing, we're just generating the next terms on from u4. So first one we'll need to find is u5, and u5 will be equal to negative 0.5 times u4 plus 4. So u5 equals negative 0.5 times 16 plus 4, which comes out as negative 4. Then we'll find u6, which is equal to negative 0.5 times u5 plus 4. So it's negative 0.5 times negative 4 plus 4, which comes out as 6. In a similar way, I'm going to ask you to pause the video and attempt the question on the right hand side. Okay, hopefully you have had time to attempt the question on the right hand side. I'll just read this with you just now. So a recurrence relation is defined as un plus 1 equals 1.5 un minus 3 with u3 equal to 4. Find the value of u5. So you can see this time we are starting at u3 and we're trying to work out u5. So we'll have to go for u4 that's in between that. So u4 is equal to 1.5 times u3 take away 3. So u4 is equal to 1.5 times 4 take away 3, which comes out as 3. So u5 then is 1.5 times the previous term to that, so 1.5 times u4 take away 3. So it's 1.5 times 3 take away 3, and that gives us a value of u5 as 1.5.